All right, so today we are going to look at, we're still looking at arithmetic sequences, which were linear. So this is still linear arithmetic sequences. So that's when you were always the same amount is either being added or subtracted. Today what we're going to look at is when it is subtracted. So it means it's decay. So we might write in here the same amount being subtracted, being taken away. So even if you want to just put a minus symbol, yeah? So we'll see in the formulas a minus of a same amount. So we call that, when the amount gets smaller, we call it depreciation. Okay, so we call it depreciation when the amount goes down, or sometimes we say decay. So something's getting smaller or reducing, it's decaying. Okay, so we know now that it's when we see a constant amount is subtracted, and often we see this in things like assets. So you might have a car will depreciate in value once you've bought it and things like that. And obviously when we look at this flat rate, we have flat rate depreciation. That's when it's the same amount is getting taken away every time. So it's like the opposite of simple interest. Okay, so when we do this, we're going to have the same as what we had last time. We're going to have a recurrence relation formula, and then we'll also have an nth term formula for it. Okay, so when we write the recurrence relation, this is what we're going to have to do for flat rate. Now, you're going to see those words written in the question. So you're going to know it's flat rate depreciation because they'll tell you. All right, so when we write a recurrence relation for it, we'll still have what it initially was. So say you had a car, you might originally buy it for $20,000, so that's what you'll say. And then you'll have this formula here that shows you the value of the car after so many terms. So we might say after so many years and that. And here is that D value again. And the D value is the amount being taken away. And this is the formula that we can use to calculate. So the formula used to calculate the D value. Okay? Now, it's going to be very simple, very like simple interest. Sorry, I should have written calculate value of D. It's very similar to simple interest, this part. Because if you look, you still got that rate. So you might want to just write a little note that R equals the percentage rate of decay. So they'll say it's going down by 2% every year or something like that. So the rate is still a rate, and it's a rate of depreciation. Now if you have a graph of this, if you were graphing it, so here you can see your car starts off at a certain price, and you can see it's going down in a straight line and it goes down in value. All right, so let's go have a look at an example. We're going to practice the recurrence relation first. So let's have a look. So a new car was purchased for $24,000. So that's them telling me a VO there. Sorry, the pen's died. Well, your laptop's up anyway, so you're not watching.
Quit it.
Okay. All right, don't worry, back on. Shh, shh, shh. All right, so VO 24,000. Okay, the car depreciates at 20% off its purchase price. When you see this wording, off its purchase price, that is a way to say flat rate. So you might need to refer to that. So that is a way to say flat rate, okay? So you might need to make note of that. So they didn't exactly say flat rate, but because they're saying the same amount every time, it is flat rate. So when they told you the 20%, they've given you the R value there. Okay, so it says model this depreciating value of the car using a recurrence relation. Okay, so when we have a VO recurrence relation, we have to write our VO, which is simple. Now we're going to have to write the Vn plus 1 rule, and we know that the only bit we have to sort of fill in or calculate is this D value. So over on the side, I'm going to work that out using the formula. So we said it was 20%, so it's 20 over 100 times the 24,000. So that's going to be 480 if you do that on your calculator. So we're going to see even 4,800. Sorry. You're going to see that on your we're going to go pop that in our formula. So we write Vn minus, and this is where we're going to say it's 4,800. We don't write the D, we calculate it. Okay, so that's a recurrence relation set up. Okay, it then says use this model to determine after 2 years. So you can see I've popped the screen dump of the calculator. This is where we put 24,000 in, press enter, and then we'll see if we write minus 4,800, we'd see answer, and then it gives us, that's the first year, and then you can just keep pressing enter and it'll give you the second year, which it tells you. So after 2 years, so V2 was 14,400. Okay, in what year will it depreciate to 0? So I'll pause it for a sec, do it on your calculator and tell me how many years it takes before it gets down to 0. Okay, so if you kept clicking down, you saw after 5 years, the value was 0. So that's what we did. All right, let's go to the next bit. So this one, they're telling us straight away. So if we see this flat rate, we'll know to go to the flat rate formulas on our summary sheet. So flat rate depreciation of a car is modelled by this. So we can see it is flat rate if we looked at it. So we might write a little note here. So this is flat rate because the same amount is being subtracted every time. Subtracted, so minus every time. Okay, so this just helps us understand it a little bit. Okay, so they're saying this is a model for after n years. So every time you take 4,800 off, that's 1 year's gone. Okay, so use this model to find the value after 2 years. So like in the last time, we have to show this when we're doing this in our exams. So we'll probably start off with VO and we'll say is 24,000. And then we're going to say V1 is found by going 24,000 minus 4,800, and we'd get an answer of 19200. And then we'll show that V2. Okay, so V2 would equal 1920 minus the 4,800, which gives this. And that's all they wanted after 2 years. And then with B, it says if the car was purchased in 2014, in what year was the car's value 0? So you said before V5 equaled 0. So therefore 2014 plus 5 years equals 2019. Okay? Yeah, you could have written straight 2019. Okay. Here is another example. So a photocopier in the office costs 6,000 when new. So they're telling me a VO then. And then it says it depreciates using flat rate. So this is where we're going to have to start highlighting it, because there's other methods of depreciation. So we have to know which method they're using. So they're using flat rate, and they told me that it's 17.5% off its new value each year. So that's a way of describing flat rate anyway. So there's the R. What is the value after 4 years? So you could, if we think about it, we know if we worked out our recurrence relation for this, it would be 6,000, and Vn plus 1 would be, we take the same, this term before, and we'd minus D. So let's work out what D is in this example. So you'd find your, remember D is this formula, so we do 17.5 over 100 times 6,000. So let's see what, that ends up being 1,500. So every time you're going to subtract 1,500, so you can just pop that in and find what's the value after 4 years. So let's just do it recursively on our
1,500 or 1,050?
1,050, sorry. Yep. Let's do it recursively on our calculator. So we type 6,000, press enter, then go minus 1,050, and then we go 1, 2, 3, 4, and we'll get the value is 8.
I'm just gonna cut off for a sec.
Yep. All right, ready? Okay. All right, so boys, obviously we can we can find the nth term. So to keep flicking in our calculators, what if I said the value, what if I started off with a big tractor, cost 200,000, every year it dropped by, 2,000 or something. Then I said, what's the value after 20 years? We don't want to keep pressing enter. We don't want to do it recursively. So we create this nth term formula, which means I can calculate the value of the asset or the object at any year. And that's what the N, or any period, that's what the N stands for. So you can see it looks very similar, and it has this D value in it, which we calculate the same way. So that's the way we're going to do. And we'd also have to change, we have to enter in what the VO is, whatever the scenario is. So this formula here is just an expanded version of that above one. And you can see, because this is the bit for D, this is the D, yeah? So they've just expanded, put that formula into it to expand it out. All right, let's go have a look at an example. So we've got here, the following recurrence relation can be used to model flat rate depreciation of asset of office furniture. Okay, so the office furniture was 24,000, the VO, and here's the recurrence relation. So this, they have given a recurrence relation there. That's what they gave there. Okay, where Vn is the value after so many years, n years. What was the initial value of the furniture? So you just need to look at what they gave you. What was the initial value of the furniture? 24,000. And how much does it decrease? Yeah, so it decreases 1,200 per year. Okay? The value of the investment after n years. So this is their way of saying, write the nth term formula. Okay, so what we're going to do is we're going to write out, I'll just copy it from the other page. Okay, so we're going to be writing this out. So Vn, now we have to change this bit. We don't write the VO, we write what actually it is, which is 12,000. And then we're going to minus. Now, I don't need to, we're going to do minus, and it's going to be n times. Now, this bit was the D amount. I don't need to work that out. It's already there. How do I know? Yeah, this is D as well, isn't it? So we can just write 1,200 there. Okay, so we saw this was 1,200. So you could actually just write it out like this. Okay, so when they ask for the value of the furniture after 6 years, they actually want V6. So we do 24,000 minus 1,200 times 6, which equals... Okay, so this ends up being the value of the furniture was 16,800 after 6 years. And how long does it take the furniture's value to decrease to 0? When they say that, it means that Vn, the value, is going to be 0. So what I do is I pop that into my nth term formula, which was this. And really, because we're asking how long, it means that n is the question, yeah? We want to know what n is. And when we have an equation like that with a letter, just one unknown, what can we do? Solve. Good. So we're going to go solve, comma, n, and we're going to find out how many years it takes for it to get to 0. Okay, so n equals 20. So we'll say how long? So we'll say 20 years. Okay, so we have another style of depreciation, which is arithmetic or linear depreciation, which it's when the same amount is coming off, but the scenario is different. The one before, where you calculate the D from a percentage of the original price, this one is they're just going to give you a set price. And it's called unit cost because they're saying every time you use the machine or something, it depreciates by this amount. So to use it, it costs the machine this much in value. So they will tell you what that is. So there's not so much calculating it, it's just reading through the question and finding it. And it still looks the same as flat rate. So it'll just be, here's the unit cost. So we might want to just write that. So they will tell you what the cost of use is. So they'll tell you which is the D value, okay? So these ones are really common with things like, say, an expensive lawnmower. Every time you use it, it drops in value. So it doesn't age as such in years, it ages in use. Same with, they love the photocopier. They say the more the photocopier, that's when it decreases in value and things like that. So let's just go and look. So this is the recurrence relation for it. Let's go do an example so we can see what I'm talking about. So it says, write down a recurrence model. So you know when you see that, you're going to have a VO and a VN plus 1. For a computer that was purchased for $1,800, which is VO, and depreciates... this is not... So this one, a professional gardener purchased a lawnmower for $270. So this is the VO. And the mower depreciates in value by $3.50 each time it used. So that's the way of saying it's unit cost depreciation, okay? Because when you get... every time it depreciates of use, that means unit cost. Okay, it says model the depreciating value of the mower using a recurrence relation form. So we know we've got to put the VO, which is the 270, and the VN plus 1, which was this, and we had to write minus D. So up here, they told us this is the D value. Every time it gets used, it's $3.50. So what I will write instead of D will be VN minus $3.50. So these two things are what we need for our answer. Okay? So what is the value after 5 uses? You can still do the same with your calculator. So you can press the 270, press enter, and then when you write to say minus $3.50, 3.5, it'll end up doing the trick for you. Now it says 5 uses, so that was V1 use, V2, V3, V4, V5. So what is the value? So V5 is $252.50. Why do I put the 0 there? Because we're talking about money, aren't we? And we should always have 2 decimal places for money. So sense, it's good to get in a good habit of that. Your calculator just writes 0.5, but I need to write 0.50 because we're talking about cents. All right, so that's that. Now this would get annoying doing this uses, and so this is where the end term one will be very more handy to have, because what happens is a photocopier will drop in like 10 cents per use, and so it will not decrease in value for over thousands of use. But so we're not going to sit there entering for 1,000 times. So we're going to want this nth term formula. So we'll see that in a minute. Let's do this one. So this is the same one, so we'll leave that. Now, except for this, how many times has the lawnmower been used before it is 250? Let's just skip to the B. So you need to type it in your calculator and see how many times. And this is where I'm saying it's going to get annoying. So we'll want to go to the end term. But let's work out what the answer is for that. Okay, so we found V6 to equal 249. So we'll say after 6 uses will be less than 250. Okay, let's go work out the nth term formula. So the nth term formula is going to be a lot easier for unit costs. So remember that you might want to write N equals the number of uses, okay? And D is obviously the cost per use, so every time it's used. All right, and so here's the formula that we're going to use. So this one, we're going to end up subbing in the value. We'll sub in the value, and the same with the D. We'll sub in the value when we have our examples. Okay, so let's go and do. So a hairdryer in a salon is purchased for $850. So that's a VO, and it depreciates at 25 cents per hour. It's in use. So they're going to do an hourly use rate. Now, you have to be careful. This 25 cents, we have to convert that to dollars because the original price was dollars. So we need that to be the same. So we're going to call, what would our D value is going to be? 0.25, exactly right. Just charging the pen. So guys, you give it a go. See if you can do that A you will done. Write down a rule to find the value of the hairdryer. So that's the nth term rule after hours of use. Because they said N, it was a use per hour. So if they say 5 hours, N is 5. Okay. Give it a go. See if you can write it down and see if it's right when we do it. Okay. All right, so this cents should be 0.25. Okay, write down our VN formula. It's going to be the original price minus 0.25 times N. Okay, so this was our VO and this was the D. Okay, what was the value of the hairdryer after 50 hours of use? So that's at V50 is the question. So if I'm finding V50, I'm going to do 850 minus 0.25 times 50. So what does... So 8... Okay, so on average, the salon will use the hairdryer for 17 hours per week. How many weeks will it take the hairdryer to half in value? So first of all, what's half its value? So you do 850 divided by 2 is 425. So we want to know, we probably want to know how many, first we want to know how many uses is the question. So that is N. So let's use our nth term formula. So I want to know when it's going to be valued at 425. So I'm using the nth term formula here. And N is going to be what I don't know. Good. We'll do solve. This is going to tell me how many hours it's going to be, which is... Okay, so it's 1,700 uses or hours, but the question was how many weeks. But we do 17 hours a week, so what will we do? So therefore, yeah, we're going to do 17 hours use divided by 17 per week. So we get 100 weeks the hairdryer, because it said here, it said 17 hours each week. So we found that the value of the hairdryer would be that after 1,700 hours use. So if you do 17 a week, there we go.